Hey guys, alright, so a video on section 3 from chapter 15, and it's called Area Under a Curve, and I'm going to work a few problems for you. So I'm going to actually start over on page, let's see, 966. I'm sorry, let me move this big sticky note. Alright, so I'm going to just start with number 10, and it says, use limits to find the area of the shaded region in each graph. Okay, so this is what I want you to do. This is actually looks like it would be hard, but it's really not. This is for when, which this particular, piece, I would basically describe that as a trapezoid. You could find the area of that using a formula, but a lot of times you have something curved like this, like on number 11 and number 12. And obviously, there's no formula like length times width or anything like that you can use to find when you have a curved shape. So this is a great way to find an area of something, to find the area of a shaded region when, there's not obviously some kind of formula that you can use, like, length times width or whatever. So that's kind of what this is used for. And what we're going to do is they've given us a function here, y equals, sorry, I've got stuff written all over my book, but we've got y equals x plus 1. So this is what I'm going to do. Okay, so on my paper, I'm going to do something called an integral, and they make this funny looking S symbol, but that's just how they do an integral. And what we're going to do, we're trying to evaluate, and you're looking at the x-axis, not the y. Sometimes that gets confusing. Make sure and always look at the x-axis. We're trying to figure out the area from 0, right here, the origin, to 2. Okay, so from 0 to 2. So on my paper, that's where, sorry, I'm pointing at the wrong thing. That's where the 0 and the 2 came from. Okay, so, and then remember, it was y equals x plus 1, and you don't have to write the y equals, you can just write the rest of it. So just write x plus 1. Okay, so what you're going to do first, that's how you start. You're going to take the antiderivative, like we learned in the previous section. You're going to take the antiderivative of x plus 1. So remember, that's x to the first. And remember, when you do an antiderivative, you add 1 to your exponent, which this would become a 2, and then divide by your new exponent. This one, remember you just add an x to it. That was, basically like x to the 0. So you add 1 and you get x to the first. Okay, so that's the antiderivative. All right, so that's how I got that. All right, so what you're going to do, you're going to plug in the top number to your new antiderivative function here. You're going to plug in the bottom number over here. And then you're going to subtract what you get. You always subtract. Okay, so the top number, plug that into your new antiderivative, see what you get. Plug in the bottom number right here, and then you just subtract. So when I did that, I got 4. When I plugged in 0, I got 0. And then 4 minus 0 is 4. Okay, I want to work 1 or 2 more, but I'll do that in a separate video.